Let's talk about free fall. So in the free fall, the motion is under the force due to Earth. So this term gravity refers to force due to Earth, right? So if there is a force, then the acceleration here is called acceleration due to gravity. So the term here G represents acceleration due to gravity. Okay. If we assume there is no air, in that situation, the hammer and the feather fall together. So this is they fall together. If we assume, if we assume negligible air resistance. But if there is air, then feather and the hammer will not fall at the same time. In this course, we are assuming there is no air resistance. That's the reason every object will fall freely with the same acceleration, which is acceleration due to gravity. So you can take the value of G is 9.8 meter per second square, or roughly you can take 10 meter per second square. The value of G is plus or minus depending on our coordinate system. Okay. So let's solve a problem based on this concept. Say a person stands on the edge of a high cliff and throws a rock straight upward with initial v of 130 meter per second. Okay, so let's make a sketch over here. Say this is my ground level. Say ground level. Say this is a cliff, for example. The person I'm assuming is here near the cliff, and he throw a stone. So certainly at that point, he's throwing the stone. It will go up, 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 and at some point it will stop. So at this point, it will stop. Right? So this is the situation. Then we need to define the coordinate system. If I choose my origin, at this point, I will consider this is my x-axis and this is my y-axis. Okay. That's the reason if I choose this coordinate system, this is the maximum height attained by the stone. I want to figure out that, and the time taken by the stone to reach at the maximum height. Okay, so we have to write the given informations here. So they give you initial velocity, initial velocity p equals 130 centimeter per second. So I convert it to meters. So basically 13 meter per second. At the highest point, it stops. So final velocity, this is V initial, this is V final, will be 0 meter per second. If I choose origin at this location, my initial displacement displacement, say y initial is equal to 0 because motion is along y-axis this time. Then final displacement y final, which is the maximum height we want to figure out. We don't know that. And we want to find the time taken by stone to reach at the maximum height. Here, only one force acting on the stone is the force due to earth. So there is acceleration due to gravity act on it or exist. Okay, so here the acceleration due to gravity, acceleration is A equals basically acceleration due to gravity, but it will be minus. The minus because in our coordinate system, I'm assuming upward positive, downward negative. So acceleration due to gravity is vertically downward, so it is minus. So be careful about this minus sign, okay? So based on this information, we have to sort out which equation works for us. So maybe if you go look at the previous slide, you can choose which best fit to find the time. So based on the given information, I can choose the first one to give the time, to find the time for this. So let's go here and find the time to for this object time. Okay, so let's see V equals V naught A times T. So this is basically V final equals V initial. In this case, acceleration is minus G times T. I can plug the value. At the highest point, it will stop, so it will be 0. V initial is 13. I just write the number plus value of G, I write minus 9.8 over T. I do a little bit algebra over here. That's how I get the time. So minus 13 equals minus 9.8 over T. I divide both sides by minus 9.8 minus 9.8. This cancel out. So T will be basically 13 over 9.8. Let's find. You can use the calculator for that. So this comes to be 1.33 seconds. So this is the time taken by the stone to reach at the maximum height. Okay. Next, we want to figure out is the height attained by the stone before reaching the reach at the top. So again, you can look at the equation, I believe, which equation fits here. You can use equation second one or third one because you have all the information required. So I will choose either of the equations to solve for that. So let's start with V squared equals V initial squared plus 2A x minus x naught. This is the standard equation. Standard equation. For the y-axis, I just write V initial, V final squared, V initial squared plus 2. A will be replaced by minus G. X will be replaced by X, or replaced by Y final minus Y initial. So at the highest point, 0 squared equals 13 squared plus 2 minus 9.8. Y final is the maximum height. We want to figure out that. This is the maximum height. If I choose origin at this point, this is initial displacement. This is the final displacement. So this minus 0. So 0 squared is 0. 13 squared minus 2, 9.8. H minus 0 is H. I do a little algebra. I believe that once I solve, I got H equals roughly 8.62 meter from the edge of the cliff. Edge of the cliff. So we figure out both time and the height to reach at the maximum height. If you understand these steps carefully, you can solve example 2, and also you can try example 3, and on the similar concept you can use the similar concept to answer these multiple choice questions. But please explain why you choose this particular answer for the multiple choice questions.